Hi, seventh graders. We are now ready to do even more complicated equations than one step or two step. So with your battleship, you practiced a whole bunch of two step, and hopefully you really got down this idea of additive inverse first, multiplicative inverse next, isolate the variable. That's still absolutely going to be really important today. But today, we have to do a little cleanup step first. And let me show you what I mean by that. You need to get out page 28. Looks like this. It's called Solving More Equations. Pens and pencils ready to go. Let's learn some more about equations. To help you understand what type of equations we're going to have and why we need to know how to deal with these, let's read this little story about someone named Pearl. Pearl spelled like that, P-U-R-L. Pearl knits and sells hats. Use the information listed to answer the big question below. Okay, let's read through this information. Pearl, actually, I'm going to take a pen, a pink pen here, and I'm going to mark up some information in here because probably if they're telling it to me, it's going to be useful to answer this big question over here. Pearl knows from experience that she can sell a slouchy hat for $35. A slouchy hat, that's like those beanies that don't fit tight on your head. Usually people wear them kind of back and then they slouch down a little bit. They require a little bit more yarn and sometimes they have fancy stitches on them. She knows if she goes to some crafting fair where she's selling her items, people will pay $35 for a hand knit slouchy hat, okay? She knows that's the maximum she can get for it. If she prices it any higher than that, nobody will buy it. And if she prices it lower than that, then maybe she's cheating herself out of some money, all right? To make a button slouch, so that's a slouchy hat with a button on the rim, Pearl uses 2 skeins of yarn. Isn't that a fun word, skeins? Did you know that's what they call, they don't call them really balls of yarn. Sometimes they do, but it's officially a skein. When you go to Joann's or whatever craft store and grab a thing of yarn, that thing is called a skein. Okay, so 2 skeins of yarn and 1 button. Besides all your normal knitting supplies that Pearl already has if she knits a lot, you also she needs to go pick out 2 skeins of yarn to make this hat and 1 button. All right, those are the other supplies. Pearl wants to sell the hat for, this is important right here, 3 times the cost of making it. That's the whole point of selling something, right? If you are a maker, if you create things, whether you create things, whatever your craft is, if you make something and you're giving it away for a gift, you don't really concern yourself with this. But if you're making an item in order to sell it, then you are concerned about stuff like this because you need to make a certain amount of profit to make it worth your time and effort. So what this means is Pearl isn't going to go out and buy the fanciest yarn there is on the market. Maybe some of you are like, Miss McGowan, there's fancy yarn. If you've never concerned yourself with this, if you don't knit or crochet or do those kind of crafts with yarn, you probably haven't looked at it much. But there's super duper cheap yarn, which can often be a scratchy acrylic yarn. It's very cheap because it's kind of scratchy and uncomfortable. And that might cost $1.99, maybe $2.99 a skein. That's very cheap yarn. You can work your way all the way up to really expensive yarn that's made out of stuff like silk and cashmere. Yeah, I mean, knit sweaters are made out of yarn, technically. It's just most of the ones you buy at the store are machine knit. Like this is knit by a machine, not by a hand, okay? So Pearl wants to sell the hat for 3 times the cost of making it. The button that she wants to use on the hat costs $2.50. So she's already picked out a button. She's like, I want this button. That button costs $2.50. All right, all that information is what Pearl knows. Over here in this gray box is Pearl's big question. The question of the day is, how much should I spend on each skein of yarn? She's gonna go to the store and she's gonna buy yarn for this hat. And she's trying to be very mathematical about it. She doesn't wanna just go and buy something because Pearl has a tendency to go to the store and buy some yarn that she loves, and then it ends up being not very cost effective. Because if you buy that super fancy silk yarn or alpaca wool yarn, you're not gonna make any profit off of it. So she's trying to be mathematical about this and figure out how much she should spend on the yarn. So right here, look what it says. Help Pearl answer her question by, ooh, we've done this before, assigning a variable. That's that whole thing we did last standard, which was also last term, where we determined the unknown. Does that sound familiar to you? What's the unknown here? We're going to call it X. Okay, so let's start with this, assign a variable. What's the big unknown? Well, it's the big question over here. How much should she spend on each skein of yarn? So the thing that we want to, that we don't know, that we want to know is cost per skein of yarn. So you learned about mathematics here and also about knitting, okay? X is the cost per skein of yarn. That's what she wants to determine. What's a reasonable amount for her to spend on this yarn so that she actually makes a profit? Okay, now, so we just did that first part. We just did that, assigning variable. I underlined it in green and then I wrote it down in green. Here's the next part, setting up an equation. And we're gonna get so much more practice on this as we move forward. Right now, we're just setting it up to help us see what types of equation we can deal with. So to set up an equation, I need to put together all this information that they gave me. You ready? And I'm gonna tell you right now, if you don't fully understand how I set up this equation, just tell yourself, I don't quite get how she did that yet. Your main standard right now is being able to solve these kinds of equations. And then next we'll work on being able to write them some more. So don't panic if you're a little confused on this. But here's what I know. I know she needs 2 skeins of yarn. So whatever the cost is, I'm gonna have to double it, right? So 2x, because it's 2 skeins, 2 times whatever the cost is. If she picks a skein of yarn that's $10, well, she's gonna spend $20 on yarn because she needs 2 of them. She also has to add to that the cost of the button, which is $2.50. Since I'm putting it into an equation to use with mathematics, I'm gonna leave that extra 0 off. 2.5 is $2.50. She knows she can sell it for $35. Here's where things get a little tricky, okay? Does she want this to equal $35? The answer is no, and that is because this represents, this expression on this side, if I just write this expression, this represents how much it costs her to make the hat. She doesn't want the cost of the hat to be $35. She would make 0 profit if she did that, right? She wants whatever this costs times 3 to be $35 because she wants that $35 to be 3 times the cost of making the hat. These are the real life types of situations that lead us to more complicated equations than just 1 step or 2 step. So your main thing, even if you didn't quite understand how I set up that equation yet, you will later, your main thing today is this part, solve the equation. And this is new and a little different because I can see the 2-step equation kind of in there. I can see those elements, but normally I'd go like this. I'd go minus 2.5, but the fact is, I don't want to subtract a 2.5 right now because truly that's not actually a 2.5. It's a 2.5 times 3. So what you have to do, and you'll hear me say this a lot in your notes today, and it's actually part of the question you need to answer when you're done with this. What you need to do first is you need to do any type of cleanup, okay? Cleanup happens on only one side of the equation because we're not using an inverse, we're just simplifying and cleaning up what we can. So for example, on this side of the equation, I can do cleanup by distributing. I'm going to use the distributive property. So 3 times 2x is 6x. 3 times 2.5, that wasn't really a 2.5, that was actually a 7.5 equals 35. I just did that cleanup there. I simplified that side of the equation so that I can work with it. Well, now that I've done that, now this is just exactly like a 2-step equation that we did last week, this week. Still in the same week, wherever we are. I don't always know when I'm recording it, what day it's gonna be for. So if they are adding 7.5, I'm going to do the additive inverse and subtract 7.5. I just did something to the Adeline side. I need to do the same thing to the Penelope side. You will need to write all of these inverse operations, but it's absolutely fine if you use a calculator after that. If you use a calculator to help you at that point, that's fine. But now you know exactly what to type in because you wrote it down for yourself. This turns to a 0, which is what I wanted. I now have 6x left on the Adeline side, and I go 35 minus 7.5 to do the math on the Penelope side. I got 27.5. Now they are multiplying by 6, so now I'm doing the multiplicative inverse. I'm going to divide by 6, and that's a weird number. I'm going to round it to 2 decimal places because I'm remembering back to what this was actually about. This was a cost per skein. This tells Pearl the perfect amount for her to spend on a skein of yarn would be $4.58. Now, is she going to go out and find that exact price? Probably not, but this does give her a really good range. This means Pearl should spend between, I don't know, $4 to $5 per skein. That gives her a range before she heads to Joann's, or if she's going to the local Willow Hill yarn shop that's at Gardner Village. That's my favorite yarn shop. You're not going to find very good yarn there for $4 to $5, but Joann's is probably a better bet for this price range. That means you're not in your cheapest yarn that's, $1.99 per skein, but you're also not, you can't get very expensive yarn if you really want to make 3 times the cost to make it. Okay, now the main idea here is solving these more complicated equations. So let's shift all of our attention and focus to that on these practice examples. All right, so the first thing that you're going to start looking at is this idea of, can I do any cleanup? So let's make a note to ourselves over here. The idea of cleaning up. So I'm going to put clean up. When Mrs. McGowan says clean up one side, what she's talking about is, can I simplify either side of the equation? And in case you forgot, this word simplify can mean a few things, and we'll make sure we understand, okay? So when you hear me say, oh, I'm cleaning up the Adeline side, or I'm cleaning up the Penelope side, this is this idea of, can I simplify anything? Can I make anything easier to read before I start solving? Okay, for example, check out number 1. So I see that I have the equal sign here, and I've got all this stuff over on the Adeline side. So the question is, can I do any cleanup? Before I even worry about the fact that this is an equation, can I just simplify some things on the Adeline side? And the answer is yes. Remember, simplifying is stuff like combining like terms. Don't forget everything we did with expressions just because we've moved forward to equations. We need all that expression stuff for what we're doing right now. So what I see is that I have like terms right there. So let's bring our brains back. That's a positive 5x and a negative 7x. Different signs subtract. Take the sign of the one that goes farther. I just did the cleanup part. And the cleanup, the reason it's on either side is because I didn't actually change anything in this equation. I just combined like terms. So that's something that only exists on one side of the equation. The cleanup was only on the Adeline side, and I still have minus 12. So because that did not change my equation at all, it also did not change the Penelope side at all. That was just the cleanup step. I looked at the Adeline side and I said, hey, can I simplify this? And I went, yes, I can, by combining like terms. Now I am ready to do my 2-step equation. It usually comes down to, if you clean everything up, it'll come down to either a 1-step or a 2-step equation, which is why we practice those so much before doing this. So I'm going to do the additive inverse, add 12. Now this is actually changing the equation. This pink part is me putting something in the equation that wasn't there before. The green part is not putting anything in, it's just combining what was already there. Does that make sense? So here, when I simplified things, that's why it only had to happen on the Adeline side, because I wasn't changing anything. Now I'm changing something with a specific purpose. So when I do that, I have to make sure I do it to both sides so I don't mess up my equation. There's my additive inverse. Now it says negative 2x equals, different signs subtract, take the second one that goes farther. Negative 8 plus 12 is 4. Now I'm going to do my multiplicative inverse, divide by negative 2, divide by negative 2, and x equals negative 2. Most of it, the whole solving part is really the same, because it's all the same inverse operations we knew. We just have to look at, can I simplify anything? Can I do any cleanup first? So again, on number 2, can I simplify anything? Well, yeah, I can do like I did on the pro question up here. I can actually distribute, and that will simplify things. Mostly because I can't even get to this stuff until I get rid of those parentheses. So I'm going to multiply and multiply. Remember, distributive property. 2 times x is 2x. 2 times -4 is -8. And I leave the Penelope side alone because I didn't actually change anything on the Adeline side. All I did was the cleanup. I did some simplifying. Now I'm ready to go +8, +8. Now I'm actually changing it, so I got to do it on both sides. I just did the additive inverse. Watch your signs on the Penelope side. Different signs subtract, take the sign of the one that goes farther. Now do your multiplicative inverse, and x equals -8. Really, the basics of all the equations, what we've been doing the last few days, it's all still here. You just have to clean up first. Is there anything you can simplify? Now, when I look at number 3 and 4, in fact, neither of these have any cleanup. There's nothing, no like terms to combine, no distributive property. I just put these on the more complicated page because there's fractions in them, and sometimes you guys get frightened by fractions. We don't need to be frightened by fractions. We know exactly what to do, and we even have a calculator if we need to help us. So the first thing I'm going to do here, because there is no cleanup, you see that? There's no cleanup. I can go right to my inverse steps. I'm going to do additive inverse. Whatever I do to the Adeline side, I need to do to the Penelope side because I'm not just cleaning up, I'm changing this equation. Those are 0. Now I have 2/3 x equals 8. This is the point where I'm trying to turn it into 1. So the easiest way to do that is just to multiply by the reciprocal. If I do that on the Adeline side, I also need to do that on the Penelope side. Turn that to 1. Here, you can cross simplify, but the easiest thing is just times the top and divide the bottom. 8 times 3 is 24. 24 divided by 2 is 12. Or type it in your calculator if you want to. That's okay too. If you've written out your inverse steps, you know exactly what to type in. You can go 8 times 3/2. You can use the fraction button there, that ABC button, and it'll get you there as well. I don't care if you type it in a calculator as long as you've already shown the inverse steps so you know exactly what to type in. Number 4 is similar. I don't have anything to clean up. I just have fractions, but this is really just a 2-step equation with fractions in it. So I'm going to go like this, -3/5, -3/5. Additive inverse with fractions works the same way. Turned it to 0. Now I have -2/5 x equals, careful here, those are same signs add, keep the common sign, and the denominators were already the same, so I left it alone. That's how you add and subtract fractions, right? Some of you will look at that and go, hey, that's -2, must be down, and you're not wrong, but I'm also just going to go through and go, turn this to 1, so I'm going to times by the reciprocal, times by the reciprocal, and then either way here, look, I can cancel some stuff. 5 divided by 5 is 1, 10, this is 5, and this is 1, and then a negative times a negative is a +5. Okay? All right. I'm going to take you through a think aloud on the last 2 to make sure we've got these done. These 2 do have some cleanup, so here we go. I'm going to show you the cleanup step. This time the cleanup is not on the Adeline side. The Adeline side is just a 20. I'm going to leave that alone. The cleanup now is on the Penelope side because I can see that those are like terms and therefore they will combine. Simplifying. So I have -5. That's just a constant. It's still there. Different signs subtract, take the sign of the one that goes farther. That's just me cleaning up the Penelope side. Cleanup is look and see if anything can simplify. Can you simplify either side of the equation? And if you can, do it first. Clean up first. Now start your inverse operations. Careful here, look at this. I'm going to turn that to 0. It would not make sense to turn that to 0 because it's stuck to the x. I just did something to the Penelope side, so I need to come over here and do it to the Adeline side. Turn that to 0. 25 equals, bring the negative with the x. That's really important because now you're dividing by -5, divide by -5 because that turns to 1. Different signs, negative. Okay, last one. Here is my cleanup right here. It's on the Penelope side, so I'm gonna just copy this on the Adeline side. Nothing's happened to that yet because I'm just cleaning up the Penelope side. -9 times x, distributive property, careful right here. -9 times -5 is +45. Okay, now I'm ready. Variables over here. This one makes sense to turn to 0. Do the same thing over here. Turn that to 0, careful right here. Same signs add, keep the common sign. -81, you can totally type it in a calculator if you need to, that's fine. Bring the negative down with the 9 because it belongs with it. So now you know to go divide by -9, divide by -9, same signs, positive. Okay, so these equations just got a little bit more complicated because maybe they have fractions in them or maybe some cleanup is required. Is there anything you can simplify or distribute? That's what the cleanup is all about. Give these a try. Let me know if you have any questions.